Hey everybody, I'm going to go through the Unit 4 practice exam for Fall 25. Okay, Chem 101. It should already be up on your Canvas and I will post the answer key later tonight. But to get started, first question, water and oxygen gas are produced from the decomposition of hydrogen peroxide. Okay, filler. Balance the following reaction, then determine how much water will be formed from 100 grams of pure hydrogen peroxide. So first things first, we're going to balance this equation, okay? So I have hydrogens and oxygens. I'm just going to count them up on both sides. I got 2 and 2, 2 and 3. Ooh, awkward. All right, I'm going to throw a 2 on here. Very nice. 2, 4, and then I'll throw 1 over here. All right, so balanced equation, fantastic. Next step, I'm going to pick out what I'm given in this question. They give me 100 grams of pure hydrogen peroxide. Nice. 100 grams, and you got to know what hydrogen peroxide is. It's going to be the H2O2. Nice. All right, okay. And what they want to know how much water will be formed. That's grams of water. So we got a pathway we're going to follow here. Going to start with grams of hydrogen peroxide. Move that onto moles of hydrogen peroxide. Use our mole ratio to convert to moles of water. And then convert back to grams of water. So one thing I will need for this is molar masses, right? Molar masses. So for H2O2, hopefully we all know how to calculate these at this point. It is 34 grams per mole. Awesome. And for H2O, we've done this one, 18 grams per mole. So these are the numbers I'm going to be using for the conversion. All right, step 1. Let's get going here. 100 grams of hydrogen peroxide. I'm going to use my molar mass to convert to moles. So 34 grams on the bottom, 1 mole on the top. Multiply this out, I'm getting I'm going to use a lot of decimals here, 941 moles H2O2. Fantastic. So step number 2, converting from moles of H2O2 to moles of H2O. For this, we're going to use our mole ratio. So I go up to the top, I look, I'm going to deal with hydrogen peroxide and water. So this is a 2 to 2. We could reduce it to a 1 to 1, but I'm just going to use the actual numbers. Do it how you want. Either way, we're getting the same number of moles of water as we have of hydrogen peroxide. Cool. So step number 3, converting this back to grams, right? So just bring those moles of H2O down. And I'm going to use the molar mass of 18 grams over 1 mole. And when I multiply that out, I get 52.94 grams of H2O. Amazing. Love that. Okay, so if I come down and look at the second one, it's kind of related to the first question, right? So if 46.7 grams of water is actually collected during the reaction, what is the percent yield? So on the first page of the exam, you will get the percent yield formula. Percent yield equals actual over theoretical yield. Our theoretical is what we just calculated right here in this question. So you're going to bring that down to the second part, and you're going to set up your equation. Percent yield equals my actual 46.7 grams over my theoretical, which is 52.94 grams. I am going to, LOL, we are not working out tonight. You're so funny. Now I'm just going to set it up, divide and multiply. And when I multiply it all out, my percent yield is 88.2%. Amazing. So that's pretty legit. I mean, it could be higher, but it could always be lower. Take the win. All right, next one. So this is very similar to the theoretical yield problem that we do, the moles to grams conversion. But in this case, we're dealing with volume and molarity, right? So we are changing up the units a little bit, but the process is very similar. So question 3, the production of hydrochloric acid is done by combining barium chloride with sulfuric acid. What is the volume of 0.18 molar barium chloride needed to completely neutralize 75 milliliters of 0.23 molar sulfuric acid? It's a very long-winded question, but we can break it down. Okay, so the first sentence is all filler. I want to focus on my numbers. Or, first of all, maybe I should balance my equation. That might be smart. Good thinking, let's balance. So I have barium, I have chlorine, I have hydrogen, I have sulfate. And I'm meaning this like SO4 sticks together on both sides. So I'm just going to count that as 1. Reactants, products, awesome. 1 barium, 2 chlorine, 2 hydrogen, 1 sulfate, 1 barium, 1 sulfate, 1 hydrogen, 1 chlorine. Well, easy fix. Stick a 2 here, and now you've got a balanced equation. Awesome. Now let's break down what we're given in this question. I'm seeing a 0.18 molar barium chloride, so that's a concentration. 0.18 molar BaCl2. They also give me 75 mils and 0.23 molar sulfuric acid. So let's say 75 mils H2SO4 and 0.23 molar H2SO4 as well. All right, so I'm thinking, since I do have 2 molarities, I'm not looking for molarity in this. I got my molarities. But the question is, what is the volume, right? So I already have a volume of H2SO4. So what they really want is volume, liters, of barium chloride. Nice. So that's in the direction we are heading. Let's see. Let's write a pathway. So I'm thinking that I'm going to start right here with liters of H2SO4. And notice, we're going to have to convert. We'll do that in a second. So we're going to go liters of H2SO4 because I know that that fits with molarity equals mole per liter. I can use it to cancel. So liters H2SO4 to moles of H2SO4. Middle step is the same as in our theoretical yield. I'll turn this into moles of what we want, which is barium chloride. And then we can convert back to liters of barium chloride, because that is what the question is asking for. So let's get started. First of all, I did point out that we have milliliters, 75 mils. I'm going to go ahead and convert that over to liters. Otherwise, I cannot do this problem, okay? So 1 liter, 1,000 milliliters. Make sure to review these before the final exam. I'm getting 0.075 liters H2SO4. Awesome. So at this point, I have everything I need, and I am just going to go ahead and start the problem. Let's see. We're going to start here with liters, so 0.075 liters of H2SO4. And I'm going to turn that into moles. How I'm going to do that? I'm going to use my molarity. Remember, these 3 things here, we must use all of them at some point in order to get our answer. So just start checking them off the list. We'll use molarity. So I'm going to say 0.23 moles per 1 liter. That's what M is, right? Multiply this out, and you will get 0.01725 moles of H2SO4, right? Because our liters will cancel. Let's bring this number down for step 2. 0.01725 moles H2SO4. And I need to convert to moles of barium chloride. How we do this, same step as in grams to moles, moles to grams, theoretical yield. Use your mole ratio. Come back up to the top here. I'm looking at barium chloride and, let me do that in a different color. Barium chloride and H2SO4. So I'm looking, I literally have a 1-to-1 ratio. So I'm going to bring that down here. 1 mole barium chloride to 1 mole H2SO4. And I will, again, get the same exact number of moles of barium chloride. Cool. So we've only got one step here, one step left. Bring your moles down. Love that we get to use the same number over and over again. And I need to convert this back to liters, all right? So remember what I said. I need to use everything in my given list, and the last thing on there is my 0.18 molarity barium chloride. So if I want moles to cancel, I'm probably going to put my 0.18 moles on the bottom, and I'll put 1 liter on the top. Dividing this out, I get 0.096 liters of barium chloride, or 96 milliliters. Either or, totally fine. Look at them. Fantastic. All right, so that's one of those big long ones there. We're going to move on to some shorter problems down here. Shorter, but kind of like reusing the same concepts, okay? So 42.3 grams of HCl is dissolved in 4.2 liters of water. What is the molarity of the solution? Okay, this requires basic understanding of molarity, or at least mathematically what it's equal to. Moles per liter. So I can pull out what I'm given. I'm given 42.3 grams in 4.2 liters. So I do have one thing I need that's already in the correct units. However, I'm going to need to convert this 42.3 grams here into moles first. So to do that, grams to moles, I need a molar mass. No way. Wow. So molar mass of HCl calculated out to be 36.45 grams per mole. Now I can convert. I can say 42.3 grams. I want to turn it into moles, so I'll put moles on the top. I will put the molar mass on the bottom. And when I divide, I will get 1.16 moles HCl. So now I can take this, put it back into the numerator of my molarity equation, set molarity equals 1.16 moles HCl over 4.2 liters, and I get 0.28 molar. Beautiful. So fun, right? So fun. All about interpretation. Remember what we learned. Grams to moles. Make it second nature. All right, next one. 76 grams of barium chloride is mixed into 230 grams of water. What is the mass percent of barium chloride in the solution? So, the question on the exam is going to be worded a lot like this. And if you're not sure where to go with this, think mass percent. Gosh, right, please. Mass percent and solution. That should lead you to say, oh, I need an equation. All the equations are on the front page of the exam. So mass percent equals mass of solute, which is what you're putting into the solution, over mass of solution. All times 100. Remember that part. So I'm just going to start plugging things in at this point, okay? So I don't have a mass percent. That's what they're asking for. So I'm going to say mass percent equals, what is my mass of solute? Well, I see that 76 grams of barium chloride is being mixed into 230 grams of water. In general, with these problems, the smaller number is going to be the mass of the solute. So it's going to be 76 grams. Now, the trick with these solution problems is that we do have to remember something here. Mass of solution equals my mass of solute plus my mass of solvent, okay? Mass of solvent. That is what you are dissolving the barium chloride into. So that would be water. So on my denominator, I have to add together 76 grams plus 230 grams, okay? And then I'm going to multiply it all by 100. Order of operations will state you're going to add these together first, then you will do the division, then you will multiply by 100, okay? When I calculate it out, it is 24.8% barium chloride. Not too bad. So yes, this is one of our mass percent problems. We'll work another one in a little bit. Next one, look at that. The percent yield of a certain reaction is always 87.4%. If the theoretical yield is 54.3 grams, what is the actual yield that you expect to get? If you are confused about this, percent yield, that's a formula. You can find that on the front page, or you can go back and reference what you did in question 2 in relation to our theoretical yield problem starting off the exam. So I'm just going to write down the formula. Percent yield equals actual over theoretical. And then you will multiply it all by 100. And now just start plugging stuff in. I do see a percent, so I'm going to assume that that's where my percent goes, right at the beginning. I'm going to set it equal to, okay, well, what's next? Set it equal to theoretical yield, 54.3 grams. Put that in place. And then it's asking, what is the actual yield? So I'm going to say A for actual yield on top. And then multiply by 100. This is going to have to be rearranged algebraically. So let's go through how to do that so we can isolate A. My first step, I'm going to divide by 100 so I can get rid of it, because I really do not need this hanging around, okay? So if I divide by 100 on both sides, I will end up with 0.874 equals actual over 54.3 grams of theoretical yield. Cool. Next step in isolating A. I'm going to come here and I'm going to multiply by my 54.3 grams. Multiply by 54.3 grams. Slay. So now I've gotten rid of it on the right side completely. And when I multiply everything out, I'm getting 47.5 grams is equal to A, my actual yield. Amazing how that works, right? Step-by-step process. Very nice. Okay, number 7. We have seen this a couple times already. I said I probably wouldn't put sucrose on the exam, but I'm probably also not telling the truth. So I just like having to calculate it. It's cute. Anyway, number 7. How many grams of sucrose are there in 300 milliliters of 4 molar sucrose solution? So again, I'm seeing a lot of conversions going on here. There's a lot of overlapping themes in my head. I think this is one of the first problems where we really have to know how to relate volume, mass, and concentration. So this is one of those where you have to apply every conversion skill you know, because we got to get our units to cancel. So breaking down what I'm given, I'm just going to write it out, right? Given 300 milliliters of sucrose, I just misspelled that, sucrose, and 4.0 molar. So I have a concentration and a volume. It wants grams. Okay, so immediately, I don't really see a way to get grams. I'm not really sure because there's no direct link, but I know it wants them. So what the heck is going on here? What I do know is, like, let's just start relating things as they appear to us. If I look at these two things, I can convert between them. I can go from milliliters to liters, and then I can go to moles. Remember? Molarity equals moles per liter. So there's a conversion in here, right? Now, how am I going to get to grams? It's easier if I break it down this way because I know that there's a conversion from moles to grams. That's using molar mass, right? So we do kind of have a rough idea of how we are going to get to our final answer. All right. So first things first, let's tackle the milliliters. It's the elephant in the room. We can't have that. We gotta convert. So I'm going to say 300 milliliters, 1 liter over 1,000 mils, and we'll be getting 0.3 liters of sucrose solution. Yay. Awesome. So now how do I go from liters to moles? Well, I do see this handy dandy molarity here. That is moles per liter. So use it as a conversion factor. Bring down your liters, 3.3 liters. And if I want to get moles, I'm probably going to put that 4.0 mole on the top, 1 liter on the bottom, okay? And that will give me 1.2 moles of sucrose. Now we're almost there, right? This is a step that we can recognize. I can go from moles to grams. But, guess what? Guess what Paige forgot? The molar mass, right? Because that's what we're going to need to calculate all this. So let's come down here real quick, and I'm going to steal this formula, and we will say that the molar mass of C12H22O11 is, oh gosh, what did I calculate? 342 grams per mole. Okay, so memorize it, learn how to calculate it. It's a big one, I know, but it's a good test that you know how to do it. So molar mass will be used in this last step of the problem, right? I'm going to put my 1 mole on the bottom, and I'm going to bring that 342 grams to the top. When I multiply together, I get 410 grams of sucrose. Wow. Sugar, sugar. Love that. Okay, wonderful. So this is a culmination of literally all the conversions we've learned in the past 2 units, or even, 3 units back. So keep practicing it. This is a really good example of a comprehensive question. All right, last page, I think. Yeah, last page. Nice. We made it. So, number 8. How many liters of 4.5 molar NaCl solution is needed to obtain 26.5 grams of NaCl? Okay, interesting. This is yet another one, a lot like number 7, that's comprehensive of these relationships between the units, right? That don't have one strict formula to follow. You just have to understand how they relate to each other. So write out your given. I got 4.5 molarity NaCl. So I have a mole per liter. Nice, nice. And then they're giving me 26.5 grams of NaCl. This is a little different than the other one, right? I'm now looking for my volume, which is where I started in number 7. So I can kind of completely reverse the process if I want. In general, my molarity is going to lie somewhere in the middle of the conversion timeline, right? So I'm going to tentatively say that, let's just say grams of NaCl is where I'll start. And then I'd really like to convert back to moles, because by converting to moles, I know that I can get to liters if I use molarity. So in general, that's, kind of what I'm going to try out here. First things first, one thing I did forget at the beginning last time, molar mass. Let's pull our molar mass of NaCl. I know that one, 58.44 grams per mole. Lovely. So starting off here, let's bring our 26.5 grams in, and let's convert it into moles. Put 1 mole on top, 58.44 grams on the bottom, and I pop out with 0.45 moles of NaCl. Great! I'm literally almost there, right? 2-step problem. Bring that 0.45 down. And now I'm going to use that molarity, right? That 4.5 moles per liter, because I want liters. So put that in the numerator and put your 4.5 moles on the bottom. And when I divide, I get 0.1 liters. Yo! Crazy, right? Incredible. So there's that. Another good comprehensive question. I enjoy these. Sorry if you guys don't. Okay, number 9. You want to prepare a 9.1 by mass solution of chemical X. How many grams of chemical X do you need to add to 200.5 grams of solution? All right, so I'm seeing a lot of different concepts here. I do see a percent, and it says by mass. So I'm kind of going to assume that this is a mass percent problem. And so I'll flip to the front, and I will write down my mass percent formula, which is mass of solute over mass solution. All of it times 100. Never forget. Okay, so let's start off. Let's start putting things in places. 9.1% equals How many grams of chemical X do you need to add to 200.5 grams of solution? So it's giving me my solution mass already. So I'm assuming that I'm solving for my mass of solute over 200.5 grams. All times 100. Oh my goodness. This is very similar to the last one, isn't it? We did one just like this, a theoretical yield and percent problem. So, let's see, I'll use red. First things first, algebraically isolate mass of solute. Divide by 100 on both sides. That is always the beginning, okay? When we do that, I pop out with 0.091 equals mass of solute over 200.5 grams. Amazing. So, we're almost there. Just one more step. Isolate mass solute. I'm going to multiply by 200.5 grams on both sides. Lovely. So, all in all, I'm going to, should I move it up there? No, I'll keep it here. When I multiply this stuff out, I get 18.2 grams equals mass of solute. Amaze. It's lovely. Yeah, that's how you do it. Algebraic isolation. Love it. All right, so that completes, I'd say, like the toughest part of the exam. Lots and lots of math. We do have a couple questions down here just because I had to fill some extra points. So let's see. Mole ratio is a really important concept, and I am glad that I put this on here. This is supposed to be an arrow. These are both supposed to be arrows. You know, iPad formatting, it changes it. But what is the mole ratio between methane and water? Good question. This would involve a little common knowledge of what methane and what water is. So I know water, right here. And then, okay, process of elimination, O2, diatomic oxygen, probably not methane. I know what this one is. This is involved in combustion reactions. It's carbon dioxide. So this must be methane. Just, if you're not sure, process of elimination, okay? So, if I want to know the mole ratio, literally just look at the coefficients, right? Looks like there's no coefficient in front of methane, so it's 1 mole of methane to 2 moles of H2O, because there's 2 here. And bam, 4 points, there you go. All right, next one. What type of reaction is this? Interesting, what type is it? Well, I have 2 reactants here, and they're forming 1 product. So this is a combination reaction. Wow. Look, we did it. And then there's a freebie question at the end. You just get 2 points. On the actual exam, it'll have you circle something. So make sure to not skip it. But yeah, this is the exam. Welcome. Hopefully it's not terribly bad, and hopefully this video helps you out while studying, right? If there are any questions, feel absolutely free to shoot me an email. Test opens tomorrow. Yeah, you know. Have a wonderful break, and I will see you all when we reconvene. Thank you, and good night.